Howdy everybody, Steve here, KM9G. I have been a fan of Redodo for a long time. And today, I've got some more Redodo stuff to share with y'all. Instead of just batteries, we've now got a solar charge controller and a 2000 watt pure sine wave inverter with remote control. Let's put them through their paces. First up, the solar charge controller. Built strong, live bold, Redodo. See if there's anything exciting and different in here. Product manual, temperature sensor, nice. Oh, it's blue. And we have a whole bunch of hardware. Shrink tubing for your hookup wires. Oh, I like these guys here. Let me show you these. These here take your big wires and you can crimp them down, and then they make them into these little lugs that you can put into the terminal blocks on the bottom of the solar charge controller. So they give you enough of those to make you happy. All the mounting screws, all the shrink hardware, wall anchors if you need anchors where you mount it. And then down in the bottom of the box, I found this little guy hanging out. This is a sticker pad for helping you to stick your temperature probe. We have seen a couple in this size and shape. I have seen them in 30, 40, and 60. The 60 was actually bigger. It had the same design language, but it was bigger. So these are all made by somebody else, and then you get to put your label on it and sell it and support it and take care of everything. So we're gonna pull down the one that's on the wall and put this one up and give it a little test with our solar panels. And it's got your typical connections on the bottom for your PV, your solar panels. Photovoltaic, big words. Battery, where your battery plugs in, and load. And usually on these guys here, the load output isn't as rich as the battery output, for lack of better terminology. Let's see what the manual says. As an example, my 100 amp hour lithium iron phosphate battery can deliver 100 amps continuous demand, continuous load on the battery terminals. This thing here, the load terminals on the solar charge controller, they're kind of there for utility, for a little helper to maybe put a light bulb in your underground basement area or inside of your work box or something like that. 20 amps max out of the load terminals on the charge controller. So if you're gonna hook up loads, hook it up directly to the battery. So I didn't see any surprises in the charge controller box. Let's see if there's any surprises in the inverter box. Oh, it's white. That's actually very bright white in the sun. We've got some hookup wires, and these are different sizes on each end, maybe? Yeah, so let's see, is it labeled what size they are? Yeah, it is. Let's get it open and we'll take a better look at it. So mounting hardware, screws, wall anchors, nice. Looks like a ground wire with a terminal on one end and an alligator clip on the other. And then this is what I was looking at. So these are doubled up in strength. So on the inverter size, it's M6, and on the battery side, it's M8. And that's fairly normal to find M8 terminals on the battery side. So red ones and black ones. More screws. There is your remote control screen, and its cable looks like an old telephone wire type. And this can be mounted, recessed inside the wall. We'll get that plugged in and show you a demo of what that looks like. There is a mounting bracket for there's two. Mounting bracket for your control panel, so you can mount it surface mount on the wall or flush mount in the wall. Fairly nice user's manual. I'm gonna get inside out of this bright sunlight, get it configured on my wall of awesome, and do some demos for you. This is my new Redodo sponsored wall of awesome. We've got the 40 amp charge controller. We've got the 2000 watt pure sine wave inverter up on the wall. And nothing is plugged in right now. I've got my solar panels kind of freestanding right there. So nothing hooked up. And I've got the inverter without anything hooked up. And there is my RF baseline of kind of the noise that's in the room. So keep an eye on that in the future segments of the video, and we'll show you what happens when we start adding more things in. First thing I'm gonna do is wire in the solar panels to the charge controller. A lot of people will say battery's gotta be plugged in first. It doesn't really matter. The charge controller will receive enough power from the solar panels to light up the little tiny computer inside. Let's get it started. I'll plug in the negative wire first because it looks like it's gonna be easier to unprotect. This is going into the negative terminal on the load side of things. And these are two 200 watt panels on the roof, which give me 400 watts total. And then we'll see it start lighting up and run through its tests. All right, those wires are in nice and tight. I like it. Let's take a look at our RF change. We're not doing any charging, we're just plugged in and powering the display. And there we go. And then I use regular Anderson power poles in most of my world, so I'm going to plug in my power poles and get that all set up. And the big reason why I'm not doing the battery first is because that thing is big and takes up a lot of space. That would be in the way of me plugging these guys in. All right, those guys there are plugged in. And then I also have a power pole distribution block, so we'll plug that into the power poles there. And this allows me to plug in a couple of extra devices on the battery side, or just to be flexible. All depends on what I feel like doing. It's the beauty of having a distribution block like that. Next up is the big battery. And this is a Redodo 165 amp hour battery. And what I can do with this in order to plug it into the charge controller is I can just hot plug it directly into the power pole distribution block. Let's get you guys focused on the tiny SA display while we plug the battery in. Did we see any jumps? Battery is all plugged in and the solar charge controller now sees it and is happy. Let's look at some of the different features that we can get on here. So first off, if you haven't seen one of these before, here is what our display does. We can go up and down. I feel like these arrows go in the wrong direction according to the way I would think. I always want to go down to see what's going on. But if we go up, it shows that the battery is 100% charged, which it is. It shows that we're putting 0 amps into the battery, which there's no reason to put amperage into a fully charged battery, but it's there just in case. We have no boost coming from the solar panels. It is 82 degrees Fahrenheit in here. It's pretty warm in here. I'd say that's pretty accurate. The E00 means no error, but it would give you a bunch of different error codes if there were any, and you can look them up inside of the manual and figure out what's going on. We're on a 12 volt system. This is your load side. We're putting solar energy into the battery. We're not doing anything with the load just yet. There's 0 amps being drawn on the load, 0 watt hours going to the load, and 33.1 volts coming from the solar panels. Nice. 14.4 volts going to the battery. Perfect. And if you want to get into the settings, there is some setting stuff in here. We can change it between Fahrenheit and Celsius. Let's keep it at Fahrenheit, and then we're back out again. So let me wire in the inverter and I'll be right back. Let's see what kind of protection we are offered on these connectors. We have a nice little plastic cap that goes over the bolt, so you're not accidentally gonna come in contact with that. We have a plastic cover. And then we have the connection terminal. You can see that there is a ring of insulation around the outside of the terminal there. And because these are front to back, it's going to be really hard to connect that solid plastic behind there, solid insulation behind there. It's going to be really hard to connect the positive and the negative to each other at the same time. And now a lot of times when you are hooking up an inverter, you could, because there are large capacitors in here, you could receive a shock. So I have one of these power resistors here. And what I do is I connect that to, it's okay to hold on to this thing because it's going to follow the path of least resistance, which is into the inverter. What I do is I hold on to this with my power lead from my battery, and then I connect it over to the inverter itself, give it a couple of seconds to work its magic, and all of that excess power spark energy goes inside of the power resistor. And then next up, I'll be able to put this on with 0 spark. Beautiful. I'm going to run this without the safety covers on it because I am space compromised on this install here. But when you do your install, make sure that you get these guys put on properly with all of the right safety covers. It's kind of like those woodworking shows where they take the guards off of the table saw. Let's take a look real quick at what ports you get with this inverter. You have 4 15 amp outlets. At a 2000 watt inverter, you're only going to get 15 amps total out of it. You've got a USB-C port, a USB-A port, you've got your power switch here, and then this is the connector for your remote. And then down here, if you wanted to hardwire this in, there are some screw terminals for 120 volt AC work. And there is an on-off switch here, and there is a backlight switch here. We've got 13.2 volts coming in from our battery, 26 degrees Celsius. That's the wrong kind of measurements. 60 hertz, 120 volt AC, and there is 0 watts going out, and it's showing that it's fully charged on the battery side. I don't know how it knows that. And that light turns our backlight on and off. And that light turns our display on and off. So basically this thing has been on, I guess, since the minute I plugged the display in, because that green light wasn't on before. So now let's take a look at our RF noise level. This is with the inverter off. We turn the inverter on with no load. And I'm not seeing much difference. Okay, let's give it a load. And so what I have here is a typical office laser printer. I'm gonna go ahead and plug that in, turn the laser printer on. You hear the inverter scream to life. So I saw 480 watts, but I was too busy paying attention to the noise it was making. There's 700, 770. She's doing pretty good. So what I'm gonna do is bring you guys back over here for some RF. We're going to turn the inverter off. It's currently putting out 0 watts because the printer is in standby mode. So inverter off now, and the printer has just shut off. Let's do it back on again. And the scale is changing, but the blue line is at -80 or so. And I'm not really seeing much change with the inverter on. Okay, so what I'm going to do now is I'm going to print out a page from the ARRL ham radio license manual. And there's our ham radio license manual printout. What I'm going to do now is I'm going to do that again and give you guys the ability to focus on the display. Let's get that glare out of the way. Let's do another print, and we'll watch the display from the inverter. 540, 620, 710, 730, 790, and we're done. We are situated right in front of all of the gear, so we're extremely near field. Let's see what happens if we change to the other side of the room. There you go, that's about 5 feet away. And then this is about 30 feet away. You can see everything has calmed down. So there's definitely some noise going on in that room, but you saw it with nothing plugged in. And then we added the solar charge controller, and we added the battery, and we added the inverter, and it's kind of what she looks like. Let's turn the inverter. The printer is off. Let's turn the inverter off. All right, the inverter is off. Let's unplug the battery, which means that the charge controller is no longer doing charge controller type stuff. And then the battery itself is a smart battery with Bluetooth 5.0 inside of it. So it's actually got its own little radio generator in there. And I am sweeping from 1 to 30 megahertz, so it's not picking up the 2.4 gigahertz from Bluetooth inside the battery. Now here is one of the fun things that my wall of awesome allows me to do. I've got charge controller plugged into battery via the distribution block, and I also have my load tester plugged in via the distribution block. So I'm going to go ahead and turn this guy here on, and we're going to draw 1 amp out of the battery. So let's bring our tiny SA back into play here. This blue line again is at -82. It's just a baseline. It's not a pass-fail mark. It's just a mark so that you can see where things are and where things aren't. And then what I'm going to do is stop the load on the battery. And I'm not seeing much change. Let's start the load on the battery again. Not seeing much change. If you can't dazzle them with details, at least you can baffle them with BS. And we've got a lot of BS that I can baffle you with. Let me show you what's going on this time. So I'll be able to draw a load from there. I'll be able to run the inverter. I'll be able to see what's going on the inverter's control panel. And I'll be able to see what's going on with the battery in real time via Bluetooth monitoring. And we can look at all the RF that's being put out by all this nonsense. So first off, I have changed this to draw 7 amps. You can see the 7 in there. Let's turn this on. And now you can see the battery is putting out some power, and we're reading pretty close to that 7 amps, but you can account for that in losses inside of the cable mess and all that jazz. Let's see what the charge controller thinks. 0.5 amp going into the battery finally, as the battery's got this. Let's turn on the inverter. Let's turn on the printer. There we go. So I'm going to turn off the printer. You guys that know a lot about batteries know that it is really hard to put power into a fully charged up battery. So I'm going to let this battery discharge a little bit using the MakerHawk electronic load device. And I'll come back in a little bit when there is more power being able to be pushed into the battery and show you what the charge controller is doing then. While I am waiting for that battery to discharge, let's take a look. This MPPT charge controller has a Bluetooth app in it. I have allowed it to see all the Bluetooth devices in my area, given it the appropriate permissions. I did not see any kind of login screen required in order to get in here. And if I look at my list of available Bluetooth devices, that first one, 12165, is a 12 volt, 165 amp hour battery. Showed you that one already. The BT-ROCC2440 is the charge controller. It's a model 2440, so that's how we do that. We are connected, and let's come up to the top. It shows it's not plugged into the battery, but it's set up for a LiFePO4, and we are configured to give out 14.4 volts. We just aren't doing it right now. We'll do that in a second. The battery bank, it's currently receiving 0.03 amps, which is probably just enough to run the display on the screen, and it's consuming 0 watts. The DC load is turned off. I can turn it on, but there's nothing connected to it. That's that 20 amp extra load terminals that are on the MPPT itself. So we'll turn that back off. You can do short circuit protection or not, which is nice. Controller has a low temperature protection, and it's saying that it's at 82.4 degrees Fahrenheit right now. Remember, it had that external probe, so you can turn that on or off, and it's saying it's in normal mode. Let's turn it off again. Off. Today's data: highest voltage 14.4, lowest voltage 0, charge amount 1 watt hour, maximum charge power 10 watts because the battery was fully charged the whole time. Historical data: there ain't going to be no historical data other than today. Highest battery bank voltage, yep. Maximum charge power is in green. You can see it as a bar chart or a line chart. And from yesterday when it was turned off until today when I turned it on, massive change. Total running 0 days. Cumulative total charge amount 1 watt hour, etc. Parameter settings. And here we go. System voltage is 12 volts, meaning it's got a 12 volt-ish battery connected to it. And you guys know that lithium iron phosphate batteries go down to like 10 volts and up to 14 point something, depending on the battery. Battery type is, it's locked. Let's unlock it. I don't know the password. It's probably in the manual, but we're going to guess that was 4 zeros. And that was a good guess. All right, battery type: lithium ion, sealed lead acid, gel cell battery, flooded lead acid, or we can do user configured. So you could actually get in here and really tweak this thing to shove as much power as possible. I don't recommend doing that unless you really know what you're doing and you have a fire extinguisher handy. A really, really good fire extinguisher. By the time 911 shows up, it's too late. Okay, so that is based on the setting for the battery, I bet. Let's change this over to sealed lead acid. Well, first, 14.4, 12.4, 10.8, 10 seconds, 5 volts. Yeah, there we go. So when you change your battery parameters, it's a display of what the parameters are down here. I'm going to go ahead and lock that again because I don't want to change it and I don't want anybody else changing it. Yep, just some device information. We'll go back to real-time monitoring, and I'm going to plug in the battery. Well, first, let's take a look at the battery. The battery is showing 97% state of charge, and we've got 8.6 amps going out. I did increase it from 7 amps to 8 amps, living on the edge here. And we're pulling out 114 watts. So when I plug in the solar charge controller, it's going to be giving watts into the battery and taking watts out of the battery. And so you're going to have to like look at the delta between those two. So let's look back out here. 14.3 volts is our battery setting. The battery bank is at 0.2 amps. I'm going to plug her in. And battery's at 13.9. We're going to start charging. There we go. MPPT is doing its thing. Maximum power points tracking. There we go. Half an amp. That's where we were before. 0.62. We're climbing. 0.7. We're getting up there. And you can see we were at 114 or so. I'm remembering. Forgive me if I'm wrong. But now that we're putting power in, we're at minus 98 instead of minus 114. So you can see that there's the delta between what's going in and what was going out. And that's what those numbers are. It was really weird for me to first see that and like I had to think about it for a second. So I really need to drain that battery down some more. Then we'll come back and take a look. I think we got this battery discharged enough. Let's go take a look. This is the Bluetooth monitor for the 165 amp hour battery. It's showing 52% state of charge. So that means we can turn this guy off. We can hook in the solar charge controller and watch some magic happen as we start getting this battery charged. So we immediately saw a little bit of a sag going into the battery. I'm gonna look at the amperage. We're putting 13 amps into that battery right now. And what does the battery say? So this was negative when we were doing a withdrawal. Now we're putting power in. We're putting in 13.3 amps. That's 13.1 amps, close enough. And we're putting in 175.6 watts, close enough. And we've got 90 amps left on the battery. So it'll be a while to get it charged up. We're saying 6 hours, 8 minutes left of recharge at this rate. 13 amps, 13.2 amps, nice. And if you remember from yesterday, we were only putting half an amp from the charge controller into the battery. And like I said, the reason for that is that battery was mostly charged up, and the closer batteries get to being mostly charged up, the harder it is to push more power in. And it was also getting kind of late. We are, what time is it? I don't know what time it is. I had to go check the clock. We're at 10:30 a.m. So we're still not at peak sun right now, but we're getting 13 amps out of 400 watts of solar panels through the 40 amp charge controller. If you do some math, the most I'm ever going to get out of those panels is going to be 30 amps at the absolute best conditions. Perfectly positioned sun, perfect temperatures, and absolutely clean panels and zero wire resistance. So we're doing a really good job with this charge controller in these solar conditions. I'm pretty happy with this guy. We saw the RFI, we saw the battery charge, we saw the inverter running, we saw all kinds of stuff. If you would like to see more stuff about this, of course, subscribe to the channel, but there are also links below that subscribe button where you can get some more info on all of the gear that I showed you here. And I think there's even a discount code down there for you. If you want to see somebody play with solar and inverters and charge controllers and batteries and battery testers and Bluetooth and all kinds of crazy stuff, this is the channel for you. Make sure you are subscribed by clicking that button right below the video. And then check this video out right here, right next, where I don't review the battery that I showed you in this video. Thanks for being awesome. I'll see you over there.